One thing that we can do with vectors is look at what are called projections. And a projection of one vector onto another is simply finding out if I wanted to find a vector v by using the vector w in some way, how would I do that? I'm going to draw a little picture here. I'm just going to draw, say, a vector w, and then a vector v. Okay. And what we're going to do is we're going to look at the projection of v onto the vector w. And all that means is we're going to take this vector w, we're going to say, if I were to extend this, okay, and I wanted to get to the vector v by first traveling in the direction of w and then perpendicular to w, what would I do, right? And so that's just forming a right triangle with the vector w, or I should say the line that the vector w lies on, and then a line that's perpendicular to it. And so this piece right here, okay, this length, that is what we're going to call the projection onto w of the vector v. Now this is what we're going to call scalar projection. In other words, it's just the length, okay, just the length of this vector here. In some textbooks and some applications, we actually would call this the component of v on w, where the projection is the actual vector itself. I'm just going to consider the projection as the scalar projection. It's just that length. And it's pretty easy to see how we can get that length using a couple of quantities here. First of all, if I look at this angle right here, we'll call the angle between the vectors theta. We can see that this length right here, I can get in terms of the magnitude of the vector v as the hypotenuse of the triangle. And this length right here, then, I have a relationship between the length, this angle, and this magnitude here. So the formula that we then get is the projection, the scalar projection of the vector v onto the vector w is the magnitude of the vector v times the cosine of the angle theta, okay, where that angle is the angle between the vectors v and w. Now, this is a very, very nice formula, but there is actually another way to write it, and that's if we go back to what we know about the dot product. The dot product, v dot w, has this form, that's the magnitude of v times the magnitude of w times the cosine of the angle. And so we can see that this piece right here, those two pieces, are that projection. And so what we can actually do is say, well, this is v dot w, but it has this extra, v dot w has that extra thing, so we can then divide out that magnitude of w. So this is another form for the projection of the vector v onto the vector w. Okay, this is both of these forms are fine, and they represent the distance in the direction of w that you would travel to get to v before turning perpendicular to it.